Hello, everybody. Welcome to the very first video in my series on computer networks. It's an interesting subject, and its knowledge is fundamental for understanding how computer works. Computer networks deal with connections between devices, which enables most of our digital world. Once we understand the subject well, we'll be able to answer questions like what happens when you type a URL in your browser? Or how exactly are emails sent and received? And how do VPNs hide our identities? And many more interesting questions like these. In this video, we'll start with an introduction to computer networks, define the internet, and understand its history and how communication works over it. Let's start with defining a network. A network is a group of interconnected things. A railway network connects cities, a social network connects friends, and a computer networks connect computers. Computer network, formally defined, is a group of interconnected computers linked with wires or wirelessly, which allows communication and resource sharing between them. For example, you are streaming a video on YouTube. There is a constant communication taking place between your PC and YouTube servers, and at the same time, you are sharing the server with millions of other people. This would not have been possible if we all were not somehow a part of the same network. Computers connected together form a computer network, and computer networks connected together form an internet. Wi-Fi setup at our schools and offices is an example of an internet. These smaller internetworks connect to larger global networks, creating the internet, the worldwide network of devices which we rely upon on a daily basis. The term internet can mean any interconnection of computer networks, but the internet refers to the global network on which you are listening to me right now. Importance of internet cannot be overstated. It underscores our jobs, entertainment, shopping, and social lives. To understand the current design of the internet, we must understand its history. We must know how it all began. It started in the 1950s during the Cold War when the US and Soviet Union were competing with each other on technological, political, and economic fronts. In 1957, the Soviet Union launched the first man-made satellite, Sputnik. This caught the US off guard, and in response they created ARPA, Advanced Research Project Agency, an agency responsible for scientific and technological advancement of the country. By 1969, ARPA built ARPANET, connecting different research institutions of the country. Many networks like ARPANET sprang up with time, and they all connected to form an early version of the modern day internet. This internet was not user friendly and was mainly used by governments and corporations. In the 1990s, Tim Berners-Lee, who, while working at CERN, invented the World Wide Web (WWW), making the internet more user friendly. It allowed people to access hyperlinked web pages using client-server model. That means you could now click on a link inside a web page and that will take you to another web page. It was now possible of www to navigate the web using browsers. Browsers like Mosaic and Netscape turned the internet into a visual clickable experience. But finding content was difficult early on. You needed the exact web addresses of the pages that you were looking for. Search engines like Yahoo and Google emerged to solve this problem. Now, after many years, we have reached a stage where our toasters and air conditioners are also connected to the internet. They are known as the Internet of Things. This was a brief history of the internet. Now, let's have a look at how communication takes place over it. How does a video call or an email get sent to the right place? To understand this, we must understand three core concepts: protocol, packets, and addressing. A protocol is a set of rules governing the exchange or transmission of data between devices. A good analogy would be when people meet, they usually say hi, talk with each other, and then say goodbye and part. It's a simple pattern that all conversations follow, and there could be other patterns depending on the situation. In the same way, devices follow certain rules to communicate, and these rules are called protocols. Here are some examples. Transmission Control Protocol, or TCP. It's for reliable data delivery. It makes sure that all the data is transferred. Hypertext Transfer Protocol, HTTP. It's for browsing websites. And User Datagram Protocol, UDP, for faster stuff like live streams where speed matters much more than complete data delivery. Next, packets. We know that at core, computers deal with zeros and ones, and so the messages that the sender receives are also made up of zeros and ones. These bits are transferred in units called packets to make transmission easier to manage. These packets move through the network on their own and get reassembled at the other end. This trick, called packet switching, keeps the internet speedy by letting lots of devices share the same connection. We'll see it in more detail later on in the series. Last, addressing. With billions of devices online, packets need to know where to go. Each device has an IP address. It's a unique digital address identifying every device on the internet. An IP version 4 address is a 32-bit number written as four numbers between 0 to 255 separated by a dot. And since we are running out of IP4 addresses, IP6 addresses use 126 bits to handle way more devices. If you want to check your own IP address, you can visit whatismyipaddress.com and you can see it there. But what if a device runs multiple applications? Say a server handles both a website and a chat app. What then? We use port numbers to sort this out. There are 16-bit numbers ranging from 0 to 65,535. Port numbers ensure that incoming data is directed to the correct application. For example, when you're using both YouTube and Discord on your device, YouTube server sends data to your device's IP address and a unique temporary port. Similarly, Discord server sends data to your device's IP address but to a different temporary port for its communication. These distinct port numbers combined with your device's IP address are called sockets that pinpoint one specific application. We have discussed protocols, packet switching, and sockets, but one might wonder who designs these protocols and systems upon which the internet functions. It's done by the Internet Society through its subbody called the Internet Engineering Task Force, or IETF. Their job is to standardize the working of the internet, which allows interoperability between different organizations. These standards are proposed in documents called Request for Comments, or RFCs. They can be proposed by anyone, and experts debate and refine them until they are ready to become standards. For example, RFC 675 lays out the transmission control protocol that we'll see in detail later on. Let's wrap up now. In this video, we covered how computer networks connect devices to share stuff, and that the internet is a global network of networks, growing from ARPANET to the Internet of Things. And devices use protocols, packet switching, and IP addresses to communicate, and it's all kept standardized by RFCs. In our next video, we'll cover access networks. It is the media through which our devices connect to the internet. I'll see you there. Thank you for listening. Goodbye.